today we're going to be getting loony. So the term loony actually comes from the Latin root is luna, so meaning the moon. And there used to be, there actually still is, a folk belief that the moon influences our behavior. As a matter of fact, you will sometimes hear people say, like, did you know that emergency rooms are more busy on full moons? Right? This actually has been studied, and it turns out they're not. So if you get an injury and it's a full moon, you don't have to worry about sitting in a line that is longer. But people used to think that the moon changed people's behavior. So somebody who acts in an aberrant way when there's a full moon is a lunatic, right? So being loony, lunatic, it all comes from this sort of old thought that our behaviors were influenced by the moon. Some things are, like recently there's a whole bunch of people who, just because of the moon, got up in the middle of the night. And that was pretty crazy to do. And we're going to be checking in with our local lunatics today. And we're going to see some really interesting patterns if we have data that was collected worldwide. And so we are hoping that we're going to have a data set today that is going to reflect a bunch of different latitudes, and we'll get to see some interesting stuff going on there. So here we are. And we're just going to play a little bit with the moon. So there are some, you can look online and find some really wonderful moon images. And I'm just using these as just a reminder to us to kind of look at I think the easiest way to sort of think of drawing the moon in its different phases is to start with that circle in the middle. And actually, I can change my screen here so that I can draw on my screen. And so let me see. I am going to draw on the screen here. We'll see how well this works. So if you start with, oh, there's a huge lag. Right, you start with a circle and you think of there being poles. Every time you're drawing a moon, the line you're going to make is going to start and stop at these poles. So we're not going to make so let's actually first do it right, where we can make a line that curves around. Let's try that again. We can make a line that curves around here. Here we go. Sort of starting and stopping at the poles, right? As this moon gets a little bit more full, it's going to curve up like that, getting closer and closer to what you'd see with a half moon. So we're not drawing our moon curves. Let's see, where is my eraser? There we go. So we're not drawing the moon curve as something like that. So that, remember, it's those poles that you're aiming for. And notice over on the side, when we don't have when we've got just a really thin crescent, you may not see even the light getting all the way to the poles there, which would be roughly about there. So you're just skinny, getting wider, and then pinching in. But here, we're actually going from pole to pole. That's kind of fun. So I like looking for images of moons online, and if you look around, you can find just some beautiful moon imagery, and there's a bunch of amateur astronomers who have just taken some exquisite pictures of the moon, and you can get them in all sorts of different states. So let's just take a look at this and think about drawing just the overall shape of the moon, and the crescent. And let's just take a little bit of moment right now, just everybody on your own little piece of paper, draw yourself a circle and draw yourself a few moon shapes. Some of the ones that are the most difficult for us to visualize are these gibbous moons. So the gibbous ones are the ones that are a little bit more than half, where you're adding a little chunk like that onto the moon. So here, you're adding a little chunk. Those get confusing for our brains to draw. And because your brain is going to, really react to this asymmetry. But using that pole-to-pole trick, you can get those. Let's just, everybody, draw yourself a few spheres and give yourself some crescents and gibbous moons, just to review that. Oh, I need to. So about the pause there. I forgot to take the cookies out of the oven. And I just burned myself, ouch, on my drawing hand. So it might be some interesting drawings from me from this point forward. But let's now take a closer look at the moon here, because I want to just show you something. This is a visualization put together by NASA of splicing together a bunch of moon photographs night after night. And I want people just first to notice the right-hand edge of this image. And note how the, let's see, I'm gonna hide, oops. Note how those craters really show up on that right-hand side. You don't see that on the left. You can see all these little impact craters on the right-hand side. And the reason is that that is where the terminator is. In this, so that the line between light and dark, the shadow of the Earth is just beginning to float across the moon here. So we're getting the start of the terminator here. And you see this is actually a useful drawing tool for anything. You will see more texture and detail right at the point where the shadow comes into light. So on the edge between shadow and light, because there you get glancing light across the surface of whatever object, here the moon, you are going to get better textural details. Now, let's take a look at this animation that they put together. And I want you just to notice there is something really weird that you're going to see. So first of all, isn't that cool? Look at those, looks like those craters are appearing and disappearing. But there's something else that's going on here. Oh, look at those craters disappearing. Look at that. Look at that. So as you go from, as the moon goes through the phases, notice that we are, first of all, always looking at the same surface of the moon. And also that it's rocking back and forth, right? So the moon is what's called tidally locked. It is locked into the gravitational field of, locked in with the gravitational field of the Earth. And so it is no longer spinning around. It's locked so that one side of it is always facing us. And one side is always facing away from us. And then you add on to that you have the dark side of the moon. So the dark side of the moon is not the side of the moon that is facing away from you. The dark side of the moon is where it's facing, is where it is facing away from the sun. So if you look at a full moon, the sun, the line of the planets is going to go from the sun past the Earth, and you see the full moon. Here, kind of getting into this, we're looking up towards the sun, and so the back of the moon is in shadow. As the moon then comes around us, we see this. So, but first of all, everybody just watch those craters just sort of magically, the texture of them appears right on that. You can use this trick in other drawings that you do. So on anything that you're drawing, if you add in more texture right at that shadow edge, that's where you are actually seeing it in real life. But don't you love, I mean, that wobble of the moon is interesting. But notice that when it is in the state of being the full moon, at any one phase, it will be in a predictable orientation. So it's coming back to the same position. The axis of it relative to us is in the same position when it is full, when it is a first quarter, when it's a last quarter, when it's a gibbous moon. This animation just blows my mind, and I absolutely love it. So all of the craters and the dark areas have been named. So they've all got their names, and I've talked to you folks before about, I love the Sea of Crises out here. There's, Sea of Tranquility, for Serenity. I mean, aren't these, they're just beautiful, wonderful. The Ocean of Storms. There's just the frigid sea. The people who were originally thinking of this were thinking that these actually were bodies of water. So this must be where the oceans are the coldest, maybe ice up by the poles, right? There's our frigid sea. I mean, this is wonderful stuff. And we can see some of the patterns of these naked eye, and but we can't really see the craters. By the way, notice how we see all the craters in this, and the details of all the little mountain ranges. So this is not a photograph that was taken of a full moon. This was taken by splicing together a bunch of successive full moons to get that shadow edge compilation so that you can actually see the texture of all the craters all the way across the moon. So when you see these sort of moon diagrams, that's usually what people are doing, not taking a picture of a full moon, because with a full moon, you can't see the texture of the craters. Isn't that neat? So if you drew the moon and you used magnification, this is an opportunity here to pull out your notes and see if there are any first of all, try to figure out, were you looking at this? Actually, let's kind of go back to it. Were you looking at this side of the moon when the moon was up last night, or were you looking at this side of the moon? Or were you looking at this side of the moon or that side of the moon? Can you figure out which side of the moon you were looking at? That would be like if you had sort of notes of where there were dark and light spaces on them. And if you magnified that either through a telescope or through binoculars and were able to get the locations of any of these objects, you can add those into your notes right now. So here's a bunch of the C's. So if you had those, if you put in areas of light and dark and were copying what you were seeing up there, you might be able to match some of those up. The ocean of storms, sea of rains. Ah, I like frigid sea better than sea of cold. I like frigid sea. We get to anyway. And also, if you this one also, this gets a little bit more complicated here, but this one you can see there are craters as well. So the craters are in orange, the seas are in blue. So just take a look at this, and I'm going to leave this up for just a moment, and we're going to see if there's any objects that, if you did magnify, this is an opportunity to try to get those on your page. And then we're going to start sharing those. Actually, first, I'm going to escape this. I'm going to duplicate that, and we are going to stop the share. There we go. All right. So wasn't that animation of the, it's beautiful. I actually just yesterday had that. Whenever I wasn't using my computer, I just kind of kept that going as this sort of continual thing, and every once in a while I'd just look at it and kind of go like, it was fun. So now we get to share. Thumb really hurts. We're going to share some of our nature journal notes from the other night. And what we want to do is we're going to have some from different latitudes. So high latitude, low latitude. So the lower your latitude, the closer you are to the equator. Higher latitude, the closer you are to the pole. And what we can do here is we are going to allow people to unmute themselves, right? And if you have a moon post to share, a moon observation to share, we want to hear from you. And what we're going to do is we're going to compile moon observations from all of your observations, and a very interesting pattern is going to emerge. A very interesting pattern is going to emerge. So if you, good, you are able to unmute yourselves. Does anybody have so for these are people who kind of got up at midnight and watched the moon come up. Does anybody have a moon observation to share? Anne Chadwick from Point Blue Conservation Science, thank you for getting up at all hours in the middle of the night. How are you doing? Good to see you.
I'm doing well, thanks. So I have a confession, is that I was in Vancouver. I'm back in Sonoma County now, but I was in Vancouver, where it's 49 degrees latitude.
Yes, yes.
North, and but it was cloudy.
Oh, killing me.
So I went to the internet, and I think that's what I would have seen is looking kind of like that. And here's my latitude and longitude. And I'm not even sure, because this is based on just a quick internet search of what it would have looked like. And I know that moonrise was supposed to be at 10:57 p.m., which, like you were saying on Tuesday, because of where it is in the time zone, it's, it was before midnight. So I don't know, does that make sense?
So what's interesting here
This
is
is the wrong way.
Is that so let's just sort of note that this is, so we've got an image that was taken from the internet, and this would be 47 degrees of latitude.
49 north. Yeah.
49 degrees north latitude. And we're going to note that this is an image taken from the internet. So I am kind of copying this down. And so I have just a quick little doodle of what you have. So there's my doodle of your notes. And so that we're going to, but I like your thinking of noting, like, this came from a web search, and maybe it is, that can get me kind of off in a wrong direction, right? But interesting. So our first data point is from a web search that had an image of what they thought the moon would look like in that place at that time. Does anybody else have, I'm going to jump over to the gallery, and are there any other moon observations that people made? Moon observations. It was a pretty big ask to get people up at midnight. I see Lucia has got a hand up. If you can unmute yourself and speak, and if you turn on your camera, Lucia, I can, there you are. I can add you in as add spotlight. Hey there, it's good to have you with us.
Hi. Good to see you. I actually did get up at midnight. I'm up late anyway, but I did see the moon, and what I saw was actually the opposite of what was just presented. So it looked like this.
So look at that. So I'm gonna, and where in the world are you calling in from?
Yeah, I'm in Sonoma also. My latitude is 38 degrees, I think.
All right, so we're gonna do 38 degrees north, and you are seeing, so this is why, that whole internet thing can get us into trouble. And what we're seeing is, I'm going to draw this with a pen because I want to distinguish it. Hold up your, okay, and about an angle like that. And the top part. Okay, interesting.
So yeah.
Yes, please continue saying.
So I was trying to figure out like where the sun would be, looking at the horizon as if I was standing here, and then what it might look like to someone who was on the North Pole, but I don't know.
Well, see, what I love about what you're doing here is you're taking it to the next level. So there's the observation that you're making, but what you're also doing is trying to visualize an explanation. to visualize an explanation. So here I am standing on the earth, and if I'm seeing this angle, where is the sun? Hold the journal up a little bit. So notice that those sun lines are pointing directly at a right angle to the T line of that shadow, to the terminator. So that's right. So the sun would be coming exactly from that angle. Oh, that's really fun. So everybody, so check out the little visualization. Like here's me, and oh look, and I'm seeing little San Francisco Bay, and so I'm getting the sense that you are looking towards the east because you're there standing on the west coast. See this little graphic? I'm gonna get rid of my screen for a second. So just gonna make your screen a little bit larger. This is a great way to think about it. And look, there's the rotation of the Earth visualized into this.
But
So
I'm not sure if it's correct. It's maybe all wrong.
All right. I know that makes sense to me, because then you're you know, if the sun is rising first on the east coast and then later on the west coast, you on the west coast are going to be rocking towards that where the sun is going to rise. So that is the right direction for the, isn't it fun to kind of figure this stuff out? So everybody, so check out this. So we have the direct observation. We also have the starting to kind of make explanations of what this would look like, and then hypothesizing about how this might look even from the North Pole. Oh, I love the little North Pole flag. Oh, I love your brain, right? So we can make our observations and we can visualize. This is exciting. This is exciting. So, and so I'm going to then also tag in here, I'm gonna add in this. That was cool. That was cool. So Avea, could I bring you on also? So during the event, you could be out there alone, but Avea and I got on telephones, and we're kind of going back and forth from, she was up in San Francisco, I was down in San Mateo. We're talking about sort of what we were seeing, kind of where, like, oh, there, what's that thing? And then so we were looking at the same moon from slightly south of where you are. And so let's see if our observations line up with Lucia's or what Anne found on the web. Shall we share that?
Yes.
Ooh. Ooh. So what I'm seeing is that I'm seeing that kind of that our angles are lining up with what Lucia saw. I like how you've got sort of different state. The moon was really playing peekaboo through the clouds when we were there, and so I like in Avea's how you've got those. You have the these different times when it is showing up there, and also she's putting in sort of decimal degrees on sort of as that moon is coming up, it then starts moving across the sky. So you've got times and directions. That's pretty cool.
Thank you. And then because I have sometimes a hard time communicating angles, I pretend that the moon is like the face of a clock. And so I noticed that the shadow was going from 4 to 10 on the clock.
Oh, what a good way to visualize it. So everybody check that out. Look at that. All right. So, I mean, where is something showing up on, so again, another kind of visual. Oh, and you've got a note of when you heard an owl calling.
Yep.
Oh, okay. See, this is why we nature journal, right? So ideas we can harvest here, like this thinking of the face of a clock, very, very helpful, very helpful in getting these angles. So I'm going to put in yours. So this is, I think I'm going to put in 3 little tally marks. We are at, I'm down here at 37 degrees, 37.5 degrees north. So at this latitude, we're getting kind of a congruence of what we're seeing with those angles. All right, that's cool. And also, I just wanted to point out to you, Bea, that
Ooh.
there you are sitting on the roof of your house, talking to me on the phone as I'm sitting out on my stool with my telescope.
Oh, that's cool. Thank you.
Yeah, that was fun. Yeah, it was. We talked before about kind of doing this in community is really more fun. When we're on the phone, we just realized that this thing is, it was much more fun just sort of being there, you know, geeking out with somebody else. Like, what are you seeing now? Like, oh, it's just, what's that little spot over there? Like, oh, I don't know what that spot is. Like, that what's impressive. Right. So it was good. It was a good time. It was a good time. Let's see. I'm now jumping back over to my gallery view. Are there any other data points, any other latitudes that we could get into this? So we've got a cluster of 3 in the San Francisco Bay Area. It was a hard ask to get everybody up that. All right. Anybody slip through it? Yeah, it can happen. It can happen. However, the reason so half moons always rise at midnight or noon, depending on which half moon it is. And the reason I chose that, even though the time was inconvenient, is that it would be easier to draw than a crescent or a gibbous moon. But I think that the hour made it really difficult for us to get a lot of data points. What I want to do is I want to show you a little experiment that you can do at home that is a great way of playing with thinking about moon phases. And then I'm going to show you a little bit of other kind of moon data from other locations around the world. All right? Because the shape of the moon tells you something about where you are in time. And the angle of the moon tells you something about your latitude. And so I've always looked at, you know, Claire Walker Leslie. She always has, anytime the moon is up, she has just in the corner, as part of her metadata, she draws in the phase of the moon that she's seen. And I never realized that hidden in that was a latitude indicator, which just makes it even more fun and next level. But let me show you an activity that you can do tonight without having to get up early. All you need to do is wait till it gets a little bit dark. And do people have, if you can find a white sphere, white is going to be best, if not any other sphere, will work. One where you will be able to see shadows on it. And what you're going to do is, you can also do this with family members, because this is an educational activity that I think is one of the most brilliant ways I've ever seen of helping people understand the phases of the moon. And not just that, to understand eclipses and all sorts of related phenomena. what you're going to do is you're going to, what you need is a dark room. You need a standing lamp that you can take the top off of. So not a room where there's a light on top. So you need some sort of standing floor lamp. And take the shield off of it, or you could just sort of take any sort of light bulb that you can have at about eye level in your room. You're going to turn off all the other lights. You're now in the dark room, and you with this one light turned on, and you have your bulb. And here's the way that it works. The light bulb is what celestial object? That's right. The light bulb is the sun. Your head is the earth, and this is the moon. So the light bulb is the sun, your head is the earth, and this is the moon. So what the moon is doing is this, right? It's going, the moon is going around the earth. Now you could walk around that light bulb. You don't need to if you wanted to kind of represent what the earth does in the course of a year, but that's not kind of what we're going to be modeling with this. We're going to be focusing on just the relationship between the sun, your head, the earth, and the moon. So what you do is you first take your ball and you are going to close one eye, which will make things easier for you. And you are going to move the ball until it blocks the light bulb. You want to move your ball to block the light bulb. And you're now looking at the back side of the ball. If the light bulb is in front of you, you're looking through one eye and you've blocked the light bulb from it, you are looking at the dark side of the moon, right? Now, so that is when it's this orientation, where you're sitting, you are the sun, right? Then the moon is here and the earth is back here. You looking at your little moon, you are going to see the dark side of the moon. And then what you do is, keeping standing where you are, you slowly start to spin yourself like this until the sun is over your right shoulder. And as you do, you look at what the light does on this ball. So you're watching the shadow move on this from here to what it does when the light is right over your shoulder. And then you continue moving around. Now, if you bring it right into the shadow of your head, that's an eclipse. That's a lunar eclipse. And so you can bring it right back there. There's your lunar eclipse. If you hold it up above the shadow of your head, you're going to see the light is now behind you. It's going from the sun to the earth to the moon. The entire surface of that is going to be lit up. What phase is that? That's right. And then you continue going around like that until you bring it back to that new moon. So you go from new to half to full to half to new again, and you can sit there spinning around. But it gets more interesting than this, because if you're doing this with a friend and you get them and to stand on the other side of the sun with their ball, so you can see their face, when they're doing this, you're going to see the shadow of their ball projected onto over their eye, right? When they're lining it up over their eye, you're going to see the shadow over their eye. What's that? Put it in the chat. Right, so if you're seeing the shadow, you're looking across and you're seeing somebody else with a shadow over their eye, that's a solar eclipse. So the solar eclipse is where the shadow of this thing, right, is going across here. It's the lunar eclipse when it goes into the shadow of your head. So you can model with this solar and lunar eclipses. It does this, once you physically are doing this, watching the shadow move across this, you'll say to yourself, I totally understand the relationship of the sun, the moon, and the earth in relationship to what is happening with all of these phases of the moon. If you stand in one place with your light bulb and you just spin around a few times, you will kinesthetically, intellectually, structurally, mechanically, completely understand it. It is such a better way of modeling it than any kind of flat paper diagram. You're using real light on a real sphere and you're going to see it happen in front of you. It will rock your world. But it gets better than this, friends. Because if you want to geek out just a little bit more, you can bring time into this. So check this out. So to bring time into this, if I remember when I'm looking at the camera here, you are my sun, right? So if I'm looking straight at the sun and I'm standing right where my nose is, so if I were on the back, so if I were like this, it's nighttime for me. I can't see any of your light. If I'm like this, I'm just starting to see the light. Oh, now I see the light. Right now, what time is it when my nose is pointing towards your camera? When your nose is pointing towards the light, what time is it? Boom. Mary in Virginia says, dude, that's noon, right? So that's noon. This is midnight, right? This is sunset, and this is sunrise. So noon, right? Going over to 6 to midnight, right? Again. So you're going around the clock. You can think of this like a clock, right? And in one day, your head in every day. So this is physically what a day is. This is a day. I'm about to demonstrate a day. That was a day. So I spin around one time, that's a day. So knowing that this is noon, right? Now, that means that 6 in the morning is over here. 6 in the evening is over there. Do I have that right? Was it those 6? What's halfway between those two? Noon and noon. It was a 24-hour clock. Let's see. Maybe get a piece of paper. So yeah, what time is it when? What time is this? What time is this? Is that 6? What time is this when it is here? Noon.
Yeah, you're right.
Numbers right? Okay, good. Sometimes numbers, we do interesting things. So now, right at sunrise, so let's try this. At what time is the full moon directly over your head? At what time does the full moon reach its highest points in the sky? If you're on the equator, it'd be directly over your head. What time would that be? What you people are like how, like, what on earth are you talking about? So what I'm saying is that if we put our moon in the full moon position, at what time does my head point straight towards that? Right? Yeah, that's midnight. So at midnight, right? So as I'm coming around here, when it's a full moon at noon, I can't see the moon because it's on the other side of the planet, right? And now I'm coming around here and I get to 6, right when the sun sets. Right when the sun sets is when the full moon rises. That's right. Ann Chadwick says the full moon always rises at sunset. So where that is on your little model here is that your nose is right here at sunset, and out of the corner of your eye, all of a sudden you're seeing the moon coming up over the horizon of your peripheral vision, right? That's at sunset. So when I turn around here, like just, oh, now I see it. So you can, using this system of this ball and thinking of you being where your nose is, you can figure out what time the full moon will rise, will set, what time a half moon will rise and set, right? You can get the moon rise and moon set times. You can figure it out by spinning your head around. Remember that just this time is noon, this time is midnight with 6s between them, right? So knowing sort of where your head, which direction your head is pointing, that's a little clock. So that part of geeking out on it kind of takes it to the next level and can be kind of hard, but it's good to sort of hurt our brains with these things, right? So what I'm going to encourage everybody to do is get yourself a little sphere, and tonight to geek out on this and mess around with it, make some diagrams and some visualizations, to just kind of get your brain sort of playing in this lunar space. If you do this thing, like hearing me talk about it right now, your brain will forget this idea soon, right? But the minute you get your own thing and you're out here kind of with your lamp in the middle of the floor and you're spinning around, you're thinking, what time is it now, right? What time is my nose on, right? Your brain will understand the relationships of all these things in such a more intuitive, robust, and profound way. And then I want to encourage everybody to make diagrams like Lucia, right? Kind of diagram that. And it will make, then whenever you see the moon in some phase, your brain will then link to this three-dimensional model, and you'll be able to intuitively understand. You could then actually look up, see this moon in the sky. You'll be able to sit down and make a little diagram of the spatial relationships of the three of you, the moon, and the sun. It's crazy. It's crazy. Right? That's our geek out challenge. I've just got one other thing for all the moon geeks. First of all, are there any other data points that we can add to from different latitudes? If so, last opportunity to share them. No. All right. So, spoiler alert coming. Avea's spotted somebody that I haven't seen.
I think I just saw both Rebecca and then Heidi raising their hands.
Yes, Rebecca.
I have a moon drawing, but it's not from this week, so it's not really a data point.
All right. Is it? Let's take a look at it. Let's take a look. Let's bring it up. We need. What is your latitude?
It's. Oh, I forgot the number.
Oh, what city state are you in?
Syracuse, New York.
Okay.
I think it's like 46 degrees north, something like that.
So you're a little bit north of us here. Okay, this is good.
And this is from, it's from a little while ago now. It's from July 31st.
Yeah, we're still good. We're still good. Ah. All right, so this was, and was that the orientation that you saw it?
And I have the drawing of the landscape.
Okay, so up in the left corner, we're seeing the actual angle of that, right?
Mm-hmm.
All right, so, and so I'm going to put down here, so I'm going to just copy, it's a little bit steeper than what we've got going on here.
And I just looked up Syracuse and it's 43 degrees north.
43 degrees north. Oh, great, thank you. It takes a village here. All right, so we've got these two data points, right? And it looks like what we're seeing on the web is not really kind of corresponding with what we've got going on here. But you notice that there's a change in the angle of what we're looking at. Oh, I love on your Jupiter, you've got the zoom in on the moons there. Oh, magnificent. Absolutely. Yeah. Moons on Jupiter. So much fun. Excellent.
That's my moon. And here's
All right. Oh, and then, yeah, and then, so what we're seeing here is, notice right along the terminator, along that line there, we're getting a bunch of craters that you're seeing on the bottom. And notice that those are seen right along the terminator line. We also have that big sort of kind of crescent shaped loop with some craters at the end. Check this out. I'm going to hold this on my end here. I'm going to go to this cam. And can you see features that match up? Right? So notice, right? So you've got this edge, you said, are these the edge of mountains? And here has been Montes Alpinius here. This big crescent here, I think we're seeing that on yours. And it is terminating in two, coming then here and then down at an angle, two craters, right? So this little crater at the end, close to the end of this little loop, that's Aristophanes. So Aristophanes is the person who figured out the circumference of the Earth by looking at shadows. And actually was the first person to, he also figured out mathematically what the tilt of the Earth's axis was, and made the first map with latitude and longitude lines on it. And so then I think we're also seeing Copernicus on yours. And then out here, two other, so there's this kind of cluster of 1, 2, 3, 4 out here. That's probably Kepler and Aristarchus. I don't even know who that is. I need to find out who this is, Aristarchus. So what you can do is you can draw the moon, and then you can figure out what craters you're looking at, and the craters are named after, I mean, there's all these cool stories going on here. Like right in here, the highest mountain on the moon is right in here on this mountain range, on that circular mountain range that you drew, the highest mountain on the moon. And here's where Apollo 15 came down. I mean, isn't that fun? Right. Hey, that's really cool moon study. Thank you so much for sharing that.
Thank you.
And Evea, there was one other.
I saw Heidi raising her hand.
Heidi, let me see if we can find gallery. Heidi, yes, I just saw you a moment ago. There you are. And
I put her, she's up.
Okay, great. Hey there. Oh, you're currently muted, Heidi. You are still muted. So you can unmute yourself. There's a button usually in the lower left-hand corner of your screen. Usually on your screen or tablet, you can be able to unmute that. Looks like we've got some technical difficulties. I'm afraid we can't get your audio right now. but hopefully we'll be able to get that fixed in the future. And so we're going to jump over, but it's good to see you though. I'm going to jump over to our friend Ray Bonto, who's crazy into astronomy, and then I'm going to show you the last little bit of geeking out with some spoilers. Add spotlight, and there we go. Ray Bonto, good to see you.
It's all cloudy here. All these 3 days, and it's still going on. But I had a question. Does anyone know any moon apps that like sun calc for the sun? And I know there's a moon calc, but there should be others. Are you sure?
So you're looking for things that will calculate and show the position of the moon and its phase from where you are.
Yes.
Anne Chadwick found one, but we discovered that the one that the image that it gave her was flipped, right? So that's why we always have to ground truth against the internet, right? So, hey, actually, this might be a metaphor about not believing everything we see on the internet these days. We need to actually do ground truthing when we get information through internet sources, that we need to check those against other sources.
Yeah, I saw there was one called moon calc, but sun calc and moon calc sounded the same, so it's probably part of the same thing.
Oh.
Yeah, but sun calc, I tried it once. It was wildly wrong. It was like 67. 1 hour later, 300 degrees azimuth.
Interesting.
Yeah. And moon calc must have some distortion too.
Yeah, it's important, when we're looking at these things to sometimes, people, a hardworking techie out there writes a cool program, but sometimes there's things that are wrong in their algorithms. So now you want to see something cool?
Yeah.
So here's a spoiler. Now, had we gotten more hits from around the world, we would have been able to make a diagram to reveal a pattern. And if you don't want to know what that is right now, then I would say mute the next section here and look away, because the spoiler is coming. Because again, this is stuff that if you are traveling, once it's safe to do, you can go to different places and look at the moon and watch it rise. And these things become extra exciting. So when you're in a different part of the world, what is the moon doing? Right? It's really, really cool. Let's take a look at our moon observation again. And so I just had to go through this again because it just makes me happy. This really makes me happy. That's beautiful. That's beautiful. What I'm going to wait till this and stop. Oh, no, I didn't want you to go yet. I want you to stop. There you go. So the two, no, that's not what I want. Nope. Ah. Oh, there I go. Now I have control. All right, so now I've got control over this. So there we are. Nope, stop, nope, Okay, I'm a rookie with this. So there are two Oh, I know what I'm going to do. I'm going to hit stop there, and now I move it. Now I have control, and there I go. All right, now, haha, there we go. So on either side, so the terminator is about here between these, going across Tycho right here, this big asteroid impact. So roughly across there. On either side, there is a dark spot right over here, the Sea of Crises. And on the other side is this one here. And Avea and I were looking at that little spot, and we're trying to figure out, like, who's that? Who is that little spot? And I found out that that's Grimaldi crater. So this is Grimaldi crater, this little black spot. You can see it through your binoculars, you can see it through a telescope. So whether you're looking at this side on a third quarter moon or this side on a first quarter moon, you'll either get to see the big Sea of Crises or Grimaldi crater. And that's kind of a good little landmark to think about kind of orientation of where you are relative to the terminator line of the moon. Again, the terminator line of the moon is roughly, whoops, let's come back. Whoa, 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 whoa. There we go. So you see how Grimaldi's on one side, Sea of Crises is on the other. Not perfect, like the letter T, but enough for you to kind of keep track of, like, this is the axis of the Earth, and of the moon, where the shadow is going to be cutting across, right? This is that my shadow line. So being able to spot that Sea of Crises or Grimaldi, you're going to be able to see those on the moon. Now, this leads me to this picture. Can you find the Sea of Crises or Grimaldi on this? And the answer is yes, right? So this is, you can see in the full moon, here's the Sea of Crises. Grimaldi is much smaller, right? Grimaldi would be over here. So here's the Sea of Crises. But what I want you to do is use Avea's clock. Noon is up here. This is roughly at 1 o'clock, right? Notice where on the clock the Sea of Crises is. So you can do this next time you're looking at the full moon, is figure out where for a full moon is my Sea of Crises. Then that gives you a sense of your latitude. Were you on the North Pole, you would see it like this. Here in the Northern Hemisphere, we see it like this. Were you to go to Kenya on the equator, you would see it right at the top. And as you go down further in the Southern Hemisphere, it swings over on the other side down to this position. So so what you're seeing is, so let's just take a look at this North Pole, South Pole pair. We'll get rid of this, right? Let's look at North Pole, South Pole for a moment. What's up in one is down in the other. If you're out there, you're looking at the moon, and you are standing on the Earth. The person who's on, if you're on the North Pole, your feet are pointing so in the opposite direction of the person in the South Pole. So what is up for you is going to be down for the person in the South Pole. So those are flipped. And right in the middle is something between those two. So let's just take a look at, so here, this should be, so where is this moon? If this is a full moon coming up, where is this moon? Let's just back up there one more time. Look at these positions. Is that an equatorial moon? Isn't that fun? Right, but wait, there's more, because look at this. If you're up in the northern hemisphere, the moon starts as a crescent that's a backward C, and then gets fuller and fuller and ends as a regular letter C. And in the southern hemisphere, the waxing crescent comes up as the letter C. And look at that. And on the equator, it comes up as a bowl. I wonder why it descends that way as well. Is that a mistake in this chart, or do we, well, no, this seems to be here. I'm gonna have to play with some models and try to figure out why that is, right? So, but isn't that fun? So the position of Grimaldi, here's Grimaldi down here, or the Sea of Crises, you can use this as an equatorial, as a latitudinal reference. Where is that on that circle of the moon? Similarly, the angle of the half moon, right? How that changes as you go from south to north. For me, this just opens up a big box of geeking out, and that's fun. So, want to encourage people to watch your moon and play with this. And a lot of the questions of the why of this, I'll bet a bunch of these can be answered by us standing in our living room with our ball, spinning around, looking at it from different angles. Let's see what we can do. And I hope that this was a ton of fun. I hope you have a ton of fun with this. I think it just makes moon watching like this. It kind of gets you into this sort of like this space. And welcome to the community of lunatics. So now we are going to bounce to our community sharing part of our workshop here. And if you've got something to share, let's hold it up. And I'm going to first bounce to our friend Ivea. Hey there.
Hey there. So I remember that you'd said that we could try and play with Venus and Mercury and why we see phases. And again, this is only a guess. So this is just me attempting to figure out why we see phases on Venus and Mercury and not on Jupiter or Saturn. And my guess, mind you, it's only a guess, is that because these are sort of so-called behind us, or at least we're between them and the sun, then we're used to seeing mostly the face that is facing the sun, which is where the light is. And with these ones, though, because they're in front of us, then we get the shadows, sort of like the way we do when the phase of the moon comes over this way. And so this is just my guess. And the lines here are sight lines, what we would be seeing as we look at them. So this is our Mercury, and then this is Venus over here. And I tried to do the shadow based off of I tried to sort of make mentally a direct line from the sun to the planet, and then put the shadow, the place where it seems like the sun is, on the exact opposite side. So this is just my guess about how that works.
That is really cool. That is really cool. What you could do is to kind of play with this more, is you could, with your lampshade off in the middle of your room, stand near, closer to your lamp, and have a friend of yours take the ball, have it be Jupiter, and walk in an orbit exterior to where you are standing, and be Jupiter going around your Earth, and watch what happens with their Jupiter.
Nice. my son's favorite planet is Jupiter, so I think that Logan would love to be Jupiter.
Logan gets to be Jupiter tonight.
Yep.
Logan gets to be Jupiter tonight. Awesome. That's really cool.
Thank you.
So and everybody, like, check out this diagram and look at this sort of like three-dimensional thinking. I love that sort of your, you know, the you've got that post of the pole there. You're thinking about, you know, where are those those sight lines. Just something that we're developing here is visual thinking strategies, right? And I also like drawing not to scale, right? This is just, oh, this is so much fun. This is really cool.
Thank you.
Thank you. I'd forgotten about that challenge. And if other people have that, but remember I said that if you did that, you get a dance in your honor.
Thanks. Yay.
Yay, how about that? Very cool.
Awesome dance.
All right, now I see that Ray Bonto's also got something to share. Ray Bonto, good to see you again.
Okay, so are we doing normal sharing or just moon?
Whatever floats your boat.
Okay. So today we saw some fungus growing on one of our trees recently.
Oh, how interesting. Is this sort of like one of those large woody fungi with those and that's a spore body on the underside. Is that the tissue? It's the pale part, the part where the spores come out?
I don't know. It's just a bit like smooth and bumpy and smooth.
Oh, that's
Smooth
really
one.
cool.
But like here's one. It's best not to touch it. I don't know what this is, and I don't want to take a risk. So have these brown bits on the back of it, and it was growing brown things below this part of the fungus.
That's cool. That's really fun. I like the so was it is the blue in there more shadow or was it bruising?
Shadow.
Oh, great. Yeah, there are actually some fungi that when you touch their spore beds, they bruise blues and purples, which is cool. A number of the boletes do that, which is really fun. I was wondering if any of these sort of shelf fungus or what also called conchs do the same. So nice fungi observation. Thank you so much for sharing that.
Is it that the moon appears in different, upside down in one place relative to the other? Because the people are upside down on one side relative to on this side relative to the universe, so that it'll go like that as you walk towards the poles, between the poles.
Yeah. So here, Kadama is right on top of the Earth, and on the other side is Water Bear, right? So if they're both looking at you, Kadama thinks you're right side up, Water Bear thinks you're upside down. If we rotate them this way, Water Bear now thinks you're right side up, and Kadama thinks you're upside down. They're both looking at the same phenomenon. This is why it's useful to have stuffies always at hand.
Oh yeah. Sounds a good model for the Earth.
Oh,
Right at the speaker.
Oh, nice. Very nice.
Disadvantage, they're always on wires, but That's just a quick thing. When's your Astro Educators Forum?
I think I don't know if I've scheduled that. I'll have to take a look at the schedule. And if not, I need to get that one on the schedule pronto, because we've been saying we're going to be doing that.
Well, it isn't, because it goes
Okay.
like some classes, no Astro Forum, and then it's just no, it's just what Educators Forum and no topic.
All right. I've just put down in my little notebook with a to-do checkbox by it. Astro Educator Forum. We'll get that one on the books. But the little thing with the, if you are an astronomy educator, this thing, I stole that from the Lawrence Hall of Science. They've got a whole curriculum written up on things that you can do with these. They are using styrofoam balls on sticks. Every kid has their own styrofoam ball. So when you're doing this with a classroom of people, you're not a teacher saying like, imagine my ball. The important thing is to get each person to have their own moon. So their own head is their own earth. And then, it is just phenomenal. But yeah, we'll get an Astro Educator Forum on the books. We've been saying we were going to do that for a while. Thanks for the reminder. Good to see you.
Okay, thank you.
Jumping back to the gallery view. Does anyone else have any other? Xenia, thank you for joining us here. I'm going to add you in there. Hey there.
Hey, Jack. So I didn't get any moon observations for today because it was cloudy last night. So that was a bummer. But right now I'm actually currently in New Brunswick, Canada, on the East Coast. So I've been seeing lots of interesting things by the ocean. So I wanted to share a few of them. One of them is I found this little crab shell right here. I didn't get to journal it yet, but
oh, that's going to be fun. I
today.
love the little eye nooks in it.
Yeah, you could tell where the eyes are. And if you look kind of like at the bottom, you can see like a few of like the bones and like it's really, really interesting.
Wow. That's cool.
Yeah, and there's also tons of mussel like shells washed up, so I'm hopefully going to journal those. We have like a bag of like full of rocks that we brought home. So and I did a few like kind of like silhouettes, I guess, watercolors. I only got to do them quickly, so I think this is a great blue heron. It's a type of heron.
Yes, absolutely. I mean, that's so distinctive from that shape that you got on there.
Yeah, so there were tons of great blue herons there, and I also did a kind of like a little oh, there it is. A little like kind of like just colors of what the ocean looks like. So you can kind of tell that there's the rocks in the ocean. I have to perfect the landscape when I go there again, but I've just been like,
wait, hold that little landscape up again, because I really like this sort of the variation that we're seeing in the water there.
Yeah. Oh, there we go.
Oh yeah. Just that all that. That water just, I love the way that watercolor just sort of mixes in with itself. Some places soft edges, some places hard edges. That feels very, very watery. And also notice that the impact of those pale lines, either left white paper or then put in with a gel pen afterwards, gives you just a hint of, foam around the rocks.
Yeah, I was trying to go for that. So yeah.
That's cool. That's really fun.
And I was also wondering at the beginning, you mentioned that people could share any events that
yes,
that's going on. So I was wondering if I could share something with the community.
Absolutely, please do.
Okay, so me and a friend of mine called Amaya, you might have seen her. She joins the workshop sometimes. So we're creating a teen nature journal club on Facebook because we feel that there needs to be more teens involved in nature journaling because you don't really generally see a lot of them around. So it's called Nature Journaling Club for Teens on Facebook if you'd like to join. And actually Jack is going to help us out with getting the word out for it. So if any of you guys want to join, just look that up, and you just have to fill out like a form for like how old you are. It's from 13 to 19, I think. Anyone's welcome to join, and yeah, hope to see you there.
Oh, that is really, really fun. And thank you so much for organizing this. That, you know, this whole kind of growing nature journaling community space, it's, you know, just, you can think about like what's missing and you can create it. You know, just like Rebecca did, saying like, nobody's really talking about words and writing, and created that space. And you're thinking like, there's not, you know, a place for teens to connect with each other. I think that would be wonderful. I think that would be a wonderful addition to it. And I will be helping you get the word out. We're going to be linking to you from my website, making announcements about it in my newsletter, and doing anything we can to help you kind of get a rich discussion going on in that space.
Thank you very much, Jack.
Absolutely. Rebecca, so you've got your hand up. Did you have a comment for Xenia?
No, but thank you for sharing, Xenia. I really liked your nature journals.
Yeah, that was really, really cool, Xenia. And also, we're just so excited about this new club that you're creating. It's absolutely fantastic.
Thank you so much. I hope to see people joining. So yeah, excited to see your journal pages.
That's right. We'll get the word out. And we've got a conference call. You, Amaya, myself, coming up soon, right?
Monday.
I'll send a Zoom link for that.
Okay, thanks, Jack.
Thank you. Hey there, Rebecca.
Hey, yeah, so I hope the teen group goes really, really well. That's so exciting. But that reminded me that I have something to share, if you guys don't mind, but I have a class coming up that's starting on Monday. It is a paid nature journaling class. It's my first time doing that. And it's called Nature Journaling for Ecological Restoration. So that's inspired by the quote from Braiding Sweetgrass, the book. That's about that. It's not just the land that's broken, but our relationship to the land. And how can we use nature journaling to try to heal that relationship, and through the storytelling aspect of nature journaling, but also learning about the science of ecology and restoration. So that'll be a small group. And it's starting on Monday, and there are still spots available. Just wanted to let you know in case anybody is interested. Thanks.
That's fantastic, and thank you for offering that. So putting together classes like this takes a lot of work, and supporting. So if the supporting people, the teachers and people who are developing that, like for a workshop like that, is a really good thing to do. So if this sounds interesting to you, also by participating in that, you help make it economically viable for people like Rebecca to put that time and that work in to make those classes for you. Some things in that you see kind of going on in the nature journaling community are at no cost, and some things there is a cost with them. And I just want to be really clear that there's no value judgment about that. A lot of the people like me who are doing things, you know, at no cost are also being supported by donations that are coming in other places. And everyone, including Rebecca, needs to sort of help. We need to sort of make this kind of sharing work for us economically. So I want to just encourage people to be also, when you are supporting classes like that, just realize that you are also being a patron who helps support people like Rebecca and myself offering these sorts of classes. And so I want to encourage people to sign up for classes like that. And it makes a huge difference to the people who are then developing and providing this. And Rebecca, thank you for putting the work together to create this restoration class. Again, I like that restoration. That's good. That's good.
Thank you.
Do you want to tell us a little bit more about the content of that?
Yeah, sure. So if you go on the link I said, there's a short video that explains the class. So it'll be 5 live Zoom classes and an end of course celebration. So the themes of the first class are the themes of the classes are how to be a story catcher, the web of life, which is about ecology as the system of relationships, intergenerational nature stories, how to use how to share our stories to inspire others, and then how to draw on everything we did so far to create our future ecological vision of we've developed this connection with the place that we're in, and what do we want it to be like in the future, and how can we start taking steps toward that future.
That's going to be, I love these sort of combinations of sort of skill development and also sort of giving us big sort of scaffolding for putting larger ideas together. I think our planet needs that kind of thinking. Thank you so much, Rebecca.
Thank you.
All right. So I'm now going to bounce back over to the gallery view here. And I see that Melina and Jack also have things to share. Melina, we're going to start with you. It's good to see you and welcome.
Thank you. I just wanted to share a page in my journal that I did at the beach near our house here on Long Island it was kind of a while ago, but during Hurricane Henry. So,
oh, wow. Let's see.
This is it. It's kind of hard to tell, isn't it? But
oh yeah, you can see those waves rolling in.
Yeah.
And how did it feel to kind of watch the skies darkening and as that approached?
Didn't hit us very hard here, but it was pretty dramatic. The ocean was really like boiling almost, and the waves were starting to form really far out.
So that's a really interesting observation, sort of the point at which those waves are starting. It just gives you a sense of just the amount of energy in that.
Yeah.
Wow. Could we see that one more time?
Yeah. Hold on.
Oh yeah. So folks, just I want to point out a couple of things that Melina is doing artistically that make this really work. So first of all, notice that just as you're kind of going back, the lines in the water representing sort of the troughs and ridges of waves, notice that they are getting smaller and closer together. And that's what gives that illusion of depth. Now notice the same thing going on in the sky. Right? So in the back, there's just a few little horizontal lines showing the bases of these clouds. As you get closer to the front, you're getting those sort of larger, more detail. Notice the back, less detail, foreground, more detail. And also just in the water, there's part of the edge of the water there where there's sort of kind of rough edge, and it kind of gives you a sense of kind of what the foam can do on these. And so those are visually some strategies that she's using here that really give you a sense of depth and movement in a little sketch like this. So it's a very challenging subject. and I like that.
Thank you.
Thank you. Thanks so much for sharing that. Let's go join Jack and see what is happening in your journal. Hey there, good to see you.
Hey, we went on a little nature walk the other day, and we were just picking up leaves and putting them in a bag and bringing them back to the house. We were walking through our neighborhood, and I nature journaled one of them.
Ooh. Oh, I love how specific this is. You really, like, this is not a generic leaf. This is this particular leaf. Isn't it interesting the way that the brown area is confined to that one little section? And then are we also zooming in on some of the veins?
That is under my microscope.
Yeah. Oh, what fun. How are you getting the thin white veins in the leaf, those thin pale veins? What is your strategy there?
The gel pen. The gel
That's
pen.
that was a gel pen.
And then
Right.
like I took a green coloring pencil that was really sharpened and like went over it to like tint it a little bit.
Great. So that was tinted with watercolor or tinted with the colored pencil?
Colored pencil.
Oh, I have never tried that. So Jack, innovating some new strategies here, tinting colored pencil. I've never thought about tinting gel pen with colored pencil. So I'll have to play with that. Thank you.
And I don't really know what this is about, but my mom wanted me to ask you if you were sharing in the Charlotte Mason conference this year. I don't really know what that is, but she wanted me to ask you that.
So the Charlotte Mason is an amazing educator who based from her systems developed a homeschooling system that is really comprehensive and rich, involving sort of a lot of looking at books and your own reading. Nature journaling is a part of Charlotte Mason's system. She didn't call it nature journaling, but way back when she was developing these things, she came up with what we now call nature journaling. So she was doing that a long time ago. And at a number of Charlotte Mason conferences, I've been invited to come and present nature journaling strategies. There are a number of different Charlotte Mason organizations that have different conferences. And so I'm not sure about which one she's talking about. For next year, I'm not at this point booked for doing any Charlotte Mason conferences, but in the past when I've gotten to roll out to those, it's one of these places where just like the discussions that you have around the dinner tables with everybody are just so rich and interesting. And youth who have been raised in this system it's fascinating. Like in some places you're there, like the adults are talking, having their own conversation, and the kids will be off in there. But in these Charlotte Mason conferences, like youth at the table will be kind of leaning in, like giving, like, and it's like, well, there's something different going on here with this system. So I love going to those Charlotte Mason conferences, and whenever they invite me, if I'm able to, I do. Recently, I've done a number of those online, and I'm just looking forward to the point again where we're all kind of, we've got a handle on our COVID situation, that we can be in person together again. I'm really, really looking forward to that. So I guess you're Jack's mom.
Hi, yes, hi Jack.
and we're just delighted to have Jack as part of this community, a real regular participant, and just share. So just for people who are kind of watching this and kind of wondering, like Jack, what are you talking about? Like kind of like the engagement of people, like people like Jack. You're doing Charlotte Mason?
Yeah, we've been doing classical conversations for, this is our 6th year, but I kind of just stumbled upon Charlotte Mason, and I have regret that we didn't start with that 6 years ago. So we are starting with that this year. We're doing Ambleside Online as our main curriculum, like with our book list and stuff, but it's been awesome. We love it. So we're going to switch over to that 100% next year.
Oh, cool. Yeah. And,
yeah,
and if you get to any of these conferences, the community is just, it's beautiful, beautiful. And like I said, just the conversations are around the table. Just like it's a different level.
I wish I had that education. You know, I feel like I'm learning along with them, you know? Yeah.
Yeah.
So I caught your video at the, I guess it was all like a Zoom conference this year. So I watched your video. I'm like, man, how cool would that be if next year it would be in person? I could take Jack with me. He could meet you. That would be awesome.
Yeah, no, I know that Jack, you know, we are going to meet up at some point, and it's gonna be, we're gonna just geek out on stuff and have a great time. I'm really looking forward to that. I don't know if that'll be at the conference, because right now I just, you know, until we get ourselves COVID safe, I'm really avoiding sort of public things, and except for sort of a few small situations where we're trying to figure out, like, you know, when can we get our next Wild Wonder live conference? Doing this sort of stuff with other people, just so much fun. It's like, yeah. I was geeking out the other night looking at the moon and just sort of being there with the veil on the telephone. I mean, that was really fun. But when you get people actually in the field together, and like, there's the moon, there you are, and you're all kind of just freaking out about it. It's really, really fun. So I hope to see you folks live at some future event, be it a Charlotte Mason conference. Those are terrific events. They really do a good job putting this together.
Well, cool. Thank you. And if not that, I know we're planning next year to go out to Monterey. So maybe we can take one of your in-person nature walks or something.
No, yeah. Even if at that point, if we're still kind of just doing things online, contact me. We will do our own just sort of get together, socially distanced nature journaling geek out. Because if you guys are out here, look me up.
Oh, we will.
And Jack, we're gonna go journaling together in Monterey. Point Lobos is going to freak you out. It is like, there are some places down there where you're like, oh man, we're totally getting our nature journal on right here. There's the places I would love to show you there, that we could journal together. That'll be fun.
Cool. Well, thank you, Jack. I appreciate it.
Great. And again, Jack, we love having you as a part of this vibrant part of this community.
Thanks.
All right. Now I'm going to jump back to the my community view. Is there anybody else that would like to share something from your journal? Thoughts, comments, ideas, and inspiration? Okay. In just a moment, I'm going to be turning off the camera. So anybody who would like to share or participate in the conversation who doesn't feel comfortable being recorded can do so. But just in closing, want to encourage people to tonight get your game on with a little sphere and a light in the middle of your house. If you're a youth and you're watching this, like, rope the whole family into it. Kind of go like, no, you got to check this out. And if you're an adult, get yourself out there, kinesthetically do this. It will change the way you think about your relationship to the moon. And again, just sort of seeing me kind of going like, I'm putting this around my head. Imagine what the shadow would be doing. No. With the real light, your head, your angle, that's what you want. I'm sort of demonstrating it so that you can then do it. But this doesn't translate into a kinesthetic understanding of those sorts of things. And the I really want to recommend that everybody do that. And now that you know these principles, the next time that you kind of get a moon and you can see sort of its orient when it's up directly over your head, it's hard to see like which end is up relative to the horizon. But when it's like when it's close to the horizon, these things, get your moon on. Get your moon on. And let's start adding the moon phase into our metadata. Because again, I mean, how fun to have a physical indicator of your latitude on your page. Kaboom. Have fun with this, everybody. Let's get out there. Let's explore nature. Take care of yourselves. Take care of the planet. Take care of each other. We're going to get through this pandemic together. And let's look for ways to kind of help each other out as individuals and as a community. And thank you all for being here. Thank you for sharing. I want to thank our elders in our community for your example. I want to thank our youth in our community for your example. You're all just, we're really sort of stepping up together. We're figuring out together these best practices. And I'm just so honored to have all of you here with us.